Okay, I'm Richmond Ankune and I'm doing a tutorial on matrix. And matrix in simple terms means that a rectangular array of numbers or variables to rows and columns. So matrix simple means that the arrangement of numbers, a rectangular arrangement of numbers or variables. Okay, so the order or how the matrices are being arranged, they are arranged into column and then rows. They are actually arranged into column and then rows. So when you write a matrix into columns and into rows, we call them the order of the matrix. So let's take an example of a matrix and try to see how we can know much about matrix. Matrices are always denoted by capital letters. So let's say A is equal to 2, 4, 3, 1. This is how we write matrices. And then this matrix, the top part, this 2 and then 3, we call it the row of the matrix. 4 and then 1, we call it also the row of the matrix. When you also come here, 2 and 4, we call it the column of the matrix, and then 3 and 1 is also called the column of the matrix. So with this, we can say that this matrix is actually 2 by 2 matrix, meaning it's having the element, the row is 2 here, and then the column 2 is 2. So we call it 2 by 2 matrix. So you can have 2 by 2 matrix, 3 by 3 matrix, 4 by 4 matrix. You can have matrices up to any number that you want to represent them. Let's talk about type of matrices. So you have types of matrices. Okay. The first one we talk about is row matrix. So the row matrix is simply a type of matrix with only one row and any number of columns. It's having only one row, but can have any number of columns at all. Example of this row matrix. Let's say A is equal to 2, 5, 10, 11. This is a type of matrix, but it's a row matrix because here I can have this one as a column 1, this is a column 2, column 3, and then column 4, but it's having only one row. So we say a row matrix is a matrix with only one row, but with any number of columns. Can have different number of columns. So with a row matrix, we can also talk about 2 as a column matrix. And as the name implies, the column matrix actually is a matrix with only one column, but with only one column and any number of rows. So let's say A is equal to 2, 5, 11, 9, 3. This is a matrix with only one column, but different number of rows. You can have 1 row, 2 row, 3 row, 4 row, 5. It's having only one column and 5 rows. So this is a type of column matrix. Let's talk about diagonal matrix. So third one or type is called the diagonal matrix. Okay. And the diagonal matrix is a type of matrix in which only the leading diagonal is having numbers, but the other places are occupied by zeros or occupied by none. It's only the leading diagonal which is occupied by non-zeros. The other places are occupied by zeros. Example of the diagonal matrix. We call it the leading diagonal. So let's say we have 2 here, 0 here, 0 here, 4 here. So the leading diagonal or the principal diagonal is this part. When the principal diagonal is non-zero and then the other part is 0, we call it a diagonal matrix. Let's talk about scalar matrix. So type 4, scalar matrix. And scalar matrix is a type of diagonal matrix. We should establish this fact. It's a type of diagonal matrix in which the leading diagonal or the principal diagonal is occupied by the same number. For example, if B is a matrix, and then we have here to be 2, this will be 0, and this will be 0, and this will be 2, it's a scalar matrix. Because the leading diagonal or the principal diagonal is being occupied by the same number, which is 2. It's 2 by 2 matrix, but the leading diagonal is occupied by the same number. Let's talk about, we can also talk about the same, let's say 3 by 3 scalar matrix. C is a matrix, and then you have here to be 2, 0, 0, 0, 2, 0, and then 0, 0, 2. So the principal diagonal or the leading diagonal here is the same. So this is what we call scalar matrix. So we move on to identity matrix. So type 5 is identity matrix. So the identity matrix is very important in dealing with matrices, and then it's being denoted by the letter I. We're represented by the letter I. So the identity matrix is a type of scalar matrix in which the principal diagonal or the leading diagonal is 1. So let's say, take example here, A is equal to 1, 0, 0, 1. So the leading diagonal here is 1. The element there are 1. So this is example of what we call identity matrix. Let's take another example. B is equal to, let's take 3 by 3 matrix. So we have 1, 0, 0, 0, 1, 0, 0, 0, 1. This is also identity matrix because the leading diagonal or the principal diagonal is 1. So we move on to what we call transpose of a matrix. Transpose of a matrix. When we talk about transpose of a matrix, what actually does it mean? So, in simple terms, transpose of a matrix means that you are interchanging the position of the row and then the column. You are interchanging the position of the row and the column. Let's say A is equal to 2, 5, 4, 5, 6, 7, 9. And they say, what is the transpose of this? To transpose this one, the transpose could be written as A bar or A transpose. is equal to, we are interchanging the position of the row. So now this row become the first column. This second row also become the second column. So how do we write it? This is the first row. We write it as the first column. So we start from here. 2, 4, 5. So the first row has been written as a column. The second row also be written as a column. So start from here. 6, 7, 9. So meaning this is the transpose of this matrix. Let's take another example. We have 8, 3, 7, 5, 6, 2. So let's find the B transpose. What I said is that the B transpose, you just interchange the position of the column and then the row. So this one is the first column. So yeah, let's write it as the first row. So we are writing this one as a column, as a row. So we start with this place and we write 8, 3, 7. This one will become the second row. So it will be 5, 6, and then 2. So this is what the term transpose of a matrix means. So let's move on to what we call operation of matrix. Operation of matrix. The operation of matrix talk about how we can add matrix, how we can subtract matrix, how we can multiply matrices. So let's talk about the first one. The first operation is addition of matrix. How do we add matrix? It's very simple that we learn how to add matrices. So let's take 2 by 2 matrix. A is equal to 2, 4, 6, 9, and then B, matrix B is equal to 1, 3, 2, 4. So let's find A plus B. In adding matrices, we add the corresponding element. So this 2, we add 1 to the 2. So get 2 plus 1 at this place. We come and add this 2 to this 6. So we add the corresponding matrix element. This 4, you add this 3 to it, so you get 4 plus 3. This 9, you add a 4 to it, have this. So now my matrix A plus B will be equal to 2 plus 1 is 3, 4 plus 3 is 7, 6 plus 2 is 8, and then 9 plus 4 is 13. So addition of matrices is very simple, that you add the corresponding elements. So let's try. So this is actually how we do the addition. So let's try one subtraction, and then the subtraction addition, they are similar. They are very similar. It is the same. So you subtract from the corresponding elements. Let's do subtraction of matrices. Subtraction of matrix. Subtraction of matrix. Okay. So this is matrix A is 4, 6, 3, 4. And then matrix B is also 2, 1, 4, 3. And then find A minus B. All that we need to do is that we write first element 4 here, And if you subtract this 2 from this 4, you are subtracting for the corresponding element. 2, come and write this 3. Subtract 1 from the 3. Write this 6. Subtract the 4 from it. Write this 4. Subtract the 3 from it. So your matrix A minus B is now giving us 2. 4 minus 2 is 2. 6 minus 4, 2. 3 minus 1, 2. 4 minus 3 is 1. So when you subtract 2 by 2 matrix, you get 2 by 2 matrix. When you add 2 by 2 matrix, you get 2 by 2 matrix. Let's move on to the one which is more serious, talking about the multiplication of matrix. Multiplication of matrix. How do you multiply? So talking about multiplication of matrices. For if you have matrix, let's say matrix A and matrix B, for you to be able to multiply these matrices, it means that the column, the condition states that for you to be able to multiply matrix A and matrix B, the column of A, the column of matrix, the column of the matrix A should be equal to the row of matrix B. So the column of matrix A should equal to the row of matrix B before you can do the multiplication. Let's take an example. Matrix A is equal to 4, 3, 2, 1. And matrix B is equal to 3, 1, 2, 2. Like this. So AB will now equal to 4, 3, 2, 1 multiplying 3, 2, 1, 2. One thing you should know here very seriously is that in multiplication of matrices, they are never commutative. If you change them A and B and write B A, you get it wrong. Okay? So this is how we multiply the matrices. The law is simple. Take the first row, operate it on the first column, and then you write it. After that, come and take the same row, operate it on the second column, and write it. So let's see how the answer is. So 4 multiplied by 3. So 4 times 3 plus 2 multiplied by 1. So 2 times 1. You take the same row, multiply by this last column. So 4 by times 2 plus 2 times 2. You come and take the second row, multiply by operate on the first column. 3 by 3 plus 1 by 1. Come and take the same row, operate it on the last column, and we get 3 times 2 plus 1 times 2. And the result becomes 3 times 4 will give me 12 plus 2. The down will give me 9 plus 1. That's 10 there. 2 give me 4 times 2 give me 8 plus 4. And then 3 times 2 give me 6 plus 2. So now I have 14. And I have 10 here. And I have 12. And I have 8. So this is how to find the product of a matrix. Thank you.